Hello guys, in this video we are asked to find the value of a for which this integral is equals to this result, right? So I'm going to let I to be equal to the integral from a to pi over 2 of 68 multiplied by the cosine square of x divided by 1 minus 17 times the sine square of x dx, right? So when I do this, then I can solve for the integral with respect to a and then equate the results to pi minus 8 times the ln of 5 over 8. So now let's solve this integral. So this integral, I'm going to, the integral from a to pi over 2, this 68, I'm going to write it as 4 times 17. And cosine square of x can be replaced with 1 minus sine square of x from the Pythagorean identities divided by 1 minus 17 multiplied by the sine square of x. Alright, so 4 is a constant. I'm going to pull it out. Then I have the integral from a to pi over 2 of, now I have 17, right? So this is going to be 17 distributed. I have 17 minus 17 times sine square of x at the numerator divided by 1 minus 17 times sine square of x, then dx. So next task is to add and subtract 1 to the numerator, right? So I have 17 minus 17 sine square of x. So next is to add and subtract 1 to the numerator. So I'm going to have plus 1 minus 1 like this. And then I'm going to divide by the denominator, which is 1 minus 17 times sine square of x and then dx. Pi is equal to 4 times the integral from a to pi over 2 of, so now 17 minus 1 is 16, right? So that is going to be 16, and then I have plus 1 minus 17 times sine square of x divided by 1 minus 17 times sine square of x dx. Now I'm going to split this integral into two different integrals. I is going to be 4 times the integral from a to pi over 2 of, first one is 16 over 1 minus 17 times sine square of x dx. And the next one is going to be plus 4, the integral from a to pi over 2 of 1 minus 17 sine square of x divided by 1 minus 17 sine square of x, right? So the second one is very easy. So there is going to be a cancellation. This one is going to cancel out beautifully, and then we are left with I to be equal to 4 times. So now 16 is a constant. I'm going to bring it out, which will become 64. Then the integral from a to pi over 2, right? Just bringing this one to multiply 4, right? And then you have 1 all over 1 minus 17 times sine square of x dx. And this one plus 4 times the integral from a to pi over 2 of 1 dx. All right. So now integrating the second one is just x. So 64, the integral from a to pi over 2 of 1 all over 1 minus 17 times sine square of x dx. This one is just x, and then we put in the limits. That's going to be 4 into pi over 2 minus a, right? So that is just integrating and plugging in the limits. So I is going to be equal to 4 times pi over 2 minus a. That is going to be 2 pi minus 4a, like this. That is distributing in with the 4, and then plus 64 multiplied by the integral from a to pi over 2 of 1 all over 1 minus 17 times sine square of x and then dx. Now I am now going to solve this integral. I'm going to call this one integral I1 and solve it in a different color. I1 is the integral from a to pi over 2 of 1 all over 1 minus 17 times sine square of x and then dx. Right, so I'm going to do a substitution here. I am going to let y to be equal to the tangent of x. So that means that x is equals to the tan inverse of y, and then dx is going to be 1 all over 1 plus y squared dy. So I have an expression for this, right? Next is to find the change in limits when x is equals to 0, the lower limit y is equal to the tan of a. Just leave it like that. And when x is pi over 2, the upper limit, y is going to be infinity. Tan of pi over 2 is infinity. And now how do you find an expression for the sine square of x in terms of y? I'm going to draw a right triangle here. So we have x as our angle. So y is equals to tan of x, that is our angle. So y is the same as y over 1, right? And then tangent of x is opposite, which is here. This is our right angle, and the adjacent to the angle x is here. Now the hypotenuse is always the square root of the sum of squares of the other two sides, right? So the square root of y squared plus 1 squared. And now we can find sine of x, I'm sorry. So sine of x is equal to opposite, which is y over hypotenuse, the square root of y squared plus 1. And now if we want sine square of x, we have to square both sides, and that is going to be y squared all over y squared plus 1. So I have everything in terms of y. You can take the integral into the y world. I1 is now the integral from the tan of a to infinity. Those are the change in limits, right? Of 1 all over 1 minus 17 multiplied by sine square of x, which is now y squared all over y squared plus 1, multiplied by dx, and dx is 1 all over 1 plus y squared dy. Alright, so I1 is equals to the integral from the tan of a to infinity of 1 all over, now multiplying this one will be y squared minus 17 y squared, and then plus 1, right? All this one is divided by the denominator, which is multiplied by 1 all over 1 plus y squared dy. And we see that these ones will cancel out beautifully. And now you are left with this. I1 is equals to the integral from the tan of a to infinity of 1 all over. This one is now what? This is negative 16, right? Negative 16 y squared plus 1, and then dy. Alright, cool. Now this negative 16, I can write it like this. The integral from the tan of a, sorry, it's not written properly. The integral from the tan of a to infinity of 1 all over, you can factorize negative 1 out, and that's going to be left with 16y squared minus 1, right, dy. So this negative 1 is a constant which I can bring out in front here. Now I have negative the integral from the tan of a to infinity of 1 all over 16y squared minus 1, and then dy. Now we are now going to solve this one. How do you solve that? This 1 over 16 can also be written as this 1 over 16y squared minus 1. If I can switch colors, 1 all over 16y squared minus 1. This can be written as 1 all over, this is like difference of two squares, which is like 4y all squared. 4y squared is the same as 16y squared minus 1. And this is the same as 1 all over, this is 4y plus 1 multiplied by 4y minus 1, like this difference of two squares. And this one we can split it like this: 1 all over 4y plus 1 minus 1 all over 4y minus 1, like this. So when we subtract this, that is going to give you 4y minus 1 minus 4y minus 1. All this one divided by the LCM, which is 4y plus 1 multiplied by 4y minus 1, like this. And now you see that this and this one will cancel, and you are left with negative 2. So what I can do is to multiply this one by negative 1/2, right? So when I multiply this one by negative 1/2, then I will have 1 all over the denominator, right? So to split, in order to integrate this one, I have to write it this way. That is 1/2 multiplied by 1 all over this. 1 all over 4y plus 1 minus 1 all over 4y minus 1. So I'm just going to replace this one with the whole of that. Alright. Now we have I1 to be equal to negative outside the integral from the tangent of a to infinity of, now replacing, we have negative 1/2, right? And this is multiplied by 1 all over 4y plus 1 minus 1 all over 4y minus 1, like this, all this one dy. So negative, negative, so 1/2 is a constant, and it's going to nullify this negative, right? So that is positive 1/2. The integral from the tan of a to infinity of 1 all over 4y plus 1 minus 1 all over 4y minus 1. Now let's split this integral into two different integrals. I1 is equals to 1/2, then the integral from the tangent of a to infinity of 1 all over 4y plus 1 dy, right, minus 1/2 the integral from the tangent of a to infinity of 1 all over 4y minus 1 dy. These are the two different integrals of I1, and then I1 is going to be equal to, now if I differentiate the denominator, I'm getting 4, but I don't have 4 at the numerator. So what I can do is I'm going to divide the integral by 4 and then multiply 4 to the numerator, right? So this is now going to be 4, which will cancel with this 4, right? The net effect is 0 plus 1 and then dy minus, I'll do the same thing here. I'm going to multiply this one by 1/4, and then I will nullify the effect by multiplying the numerator by 4, right? So I have 4 here divided by 4y minus 1 and then dy. All right, so I1 is equals to, this is 1 over 8 now. Now I see that the derivative of the denominator is the numerator, and that the resulting value of the integral is the ln of 4y plus 1, like this, minus 1 over 8, the second one, the derivative of this is the numerator, and that is going to be the ln of the denominator, which is 4y minus 1. The limits of integration from the tan of a to infinity. Now 1 over 8 is common. I have 1 over 8, and then the ln of this minus the ln of that, using the laws of logarithm, that is going to be the ln of 4y plus 1 all over 4y minus 1, like this, the limits of integration from the tangent of a to infinity. Alright, so now let's plug in the limits and see what we will get. Now for us to evaluate the limit as it goes to infinity, this is what we do. We have 1 over 8, and now we are going to take the limit, right? So the limit as y approaches infinity of the ln of this. So in order for me to take the limit as y goes to infinity, I have to divide the numerator and denominator by y. I'm going to have 4y plus 1 all over y, and I'll do the same thing to the denominator, right? So I'm going to have 4y plus 1 all over y, and I will do the same thing to the denominator, right? Because I'm taking the limit as y approaches infinity, and then minus, plugging in the lower limit, that is going to be the ln of what really, that is going to be 4 times the tangent of a, just replacing y with the tangent of a, divided by 4 times the tangent of a minus 1, like this, all close by this, and multiply by 1/8 in front. So 1/8, and then we have the ln of the limits, right? So the ln of the limit as y approaches infinity of, now if you are dividing, that is going to be 4 plus 1 over y all over 4 minus 1 over y, like this, minus the limit, the ln of 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1, like this. Okay, so as y is approaching infinity, this is approaching 0 and this is approaching 0. So we are left with 4 over 4, and 4 over 4 is 1. So I1 is going to be 1/8, and then we have the ln of 1, right, minus the ln of this guy. So that is 4 times the tangent of a plus 1 all over 4 times the tangent of a, right, minus 1. So ln of 1 is 0. So that is left with this one, multiply by 1 over 8 in front, and I1 is simplifying to negative 1 over 8, and then the ln of this 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1, like this. Now that we have I1, we can go back and replace it in our integral here. So this one, we are coming back here. So I is equals to 2 pi minus 4a plus 64 times I1. 2 pi minus 4a, right? I, which we want, is equals to 2 pi minus 4a and then plus 64 times I1. This is what we want. So I is equal to 2 pi minus 4a, and this is added to 64 multiplied by I1, and I1 is 1 over 8 negative. I'm sorry about that. And then we have the ln of 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1, like this. Okay, so 64 over 8 is 8, right? So we have 2 pi minus 4a, and this is now minus 8 because 64 over 8 is 8, and then the ln of this, which is 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1. Now it's time for us to find the value of a. So we have to equate this to what is given to us, right? We are asked to find the value of a for which the integral is equals to a certain answer or constant. So we are going to equate what we got to be equal to this. So equating that to pi minus 8 times ln of 5 over 3. So now let's do that and find the value of a, right? So that is what we have. So now we are now going to equate this resulting value of the integral to the answer that is given to us in order to find a. So 2 pi minus 4a, this one, minus 8 times the ln of 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1. We are going to equate this one to the resulting value of the integral, which is given to us as pi minus 8 times the ln of 5 over 3. Right, so now let's do the comparison and find the value of a. So by comparison, right, by comparison, so when you are doing the comparison, we can see that this one, 2 pi minus 4a, this is the same as we have pi here, right? So we have this one to be equal to pi, right? We have 8 to be equal to 8, right? And the idea is that the ln of this guy is equal to the ln of 5 over 3. So that is the comparison that we are drawing here. So 2 pi minus 4a is equals to pi. Let's try to find pi here and a here and see what we get. So that implies that 4a is equal to 2 pi minus pi, that is going to be pi, and a is going to be pi over 4, right, for the first one. Now if we are doing the comparison for the second one, 8 is equals to 8. So that means that the ln of this guy, 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1. This one is equal to the ln of 5 over 3, like this. Alright, so now how can we solve for a here? So in order to solve for a, we have to eliminate the natural log. So we have to take the exponent on both sides. So we can just take e on both sides. So we have like e of this and we have e of that, right? The e is going to cancel the natural log, and that is going to be left with 4 times the tangent of a plus 1 all over 4 times the tangent of a minus 1, and that is equals to this e will cancel the natural log, and that is left with 5 over 3. All right, so now we can solve this for a to see whether it will match with a in the first comparison. So that is going to be cross multiplication. That is 3 times 4 times the tangent of a plus 1, right? And this is equals to 5 multiplied by 4 times the tangent of a minus 1. Cool. Now let's multiply. This is 12. The tangent of a plus 3, and that is equals to 20. The tangent of a minus 5. So let's subtract 12 tangent of A from both sides. That is going to be 20 the tangent of A minus 12 the tangent of A, and that is equals to 3 plus 5, right? So this is 8, right? 8 the tangent of A, and that is equals to that is going to be equal to what really? So we have, this is 12 plus 3, and that is 20 minus 5, right? So when we are subtracting, that is going to be 20 minus 12, and that is equals to 3 plus 5, and that is equals to 8 as well. Okay, all right, so we can divide both sides by 8, so that is going to be tangent of A, which is equals to 1. If we want A, we have to take the tan inverse on both sides. So we are now going to take the tan inverse on both sides, and when we do that, we have the tan inverse of the tangent of A, and that is equals to the tan inverse of 1. So this isolates A to be equal to tan inverse of 1 is pi over 4. So this pi over 4 is matching with the pi over 4 that we got from the first comparison. So therefore the value of A is equals to pi over 4. Therefore A is equals to pi over 4. So that means that if we integrate the integrand, right? So the integrand that we are given, so that means that here, so the question here is that A is pi over 4. That means that if we integrate from pi over 4, which is A, to pi over 2, the upper limit of 68 multiplied by the cosine square of x all over 1 minus 17 times the sine square of x dx, that should give you this answer. So that is the resulting value of A. Yeah, so if you find this video helpful, please give me a thumbs up and support my channel by subscribing to Calculus Diaries so that I'll continue uploading engaging tutorials on integrals. I thank you, and I'll see you in the next one. Bye bye.